Hi, this is Hai Xiaowang, and today we are going to talk about binary tree vertical order traversals. And given the root of the binary tree, the vertical order traversal is node values from the top to bottom and column by column. And if the two nodes are in the same rows and its column, the order should be from left to right. And let's just go through the examples for better explanations. And for example 1, it will return from the left column to right column, which is 9, and 3, 15, and 20, and 7. Now let's go through a more complex example, which is example 2. And here, we should start from the 4, and 9, and 3, 0, 1. And for each column, we from top to bottom, and for the same level, we just start from left to right, and then we come to 8 and 7. So basically, it's we should denote when we traversal the tree, we should store the informations of the columns and rows for each node. And actually, we can use a hash map to store that kind of information, and the keys is the column, because we should first start by columns, and for its values, it should has a tuple which contains two values, and the first element is the node values, because we should output with node values, and the second element should be its rows. Denotes for which row the node are in the which row the nodes are in the tree. And after doing that, we have the dictionary that so we can just sort the keys. So we start and that means we just start from the left column to right columns, and for each columns we just sort its values, which is a list of the tuples sorted by its rows. And that means that if some cases like that, 0, 1, we will no, for case for 3 and 0, we will start from the 3 and then 0, then 1. Cause we should do the recursion like first go to left and then go to right, and so it will visitate the 0 first and then will 1. And so that's that's all about logic behind these problems. So let's just code it out. And for the parameters of the input for DFS functions, there are three parameters. The first is the node, and the second is the row informations, and third is column informations. If not node, we just return because we have nothing to do. And if not, this is a G, which is the one. Append, which is node double, and also the C. This is the R, and then the FS. Right, and cell G should be collections. It's a default dictionaries, which it sets the default to be a list. Then we just DFS from root and 0 and 0. I forgot to write. If we just start from the this node, and if we go to the left, actually the column, the row will be +1 and column will be -1. And for the node right, the row will be +1 and the column will be +1, because we want to from the left column to right column. So this should be -1, and this should be 0, and this should be 1, and so that we can sort it from small to big, and just then enumerate each columns. Order will be just list sorted list of strategy keys. And for each column, we just sort by its row informations, which is the second element here. So we just write this, and this is list of the that we should output this as our result. So call number order, and this means that we just because this is already in order, and we just enumerate from the left column to right columns, and for each columns, its element is already sorted by its row information. So we just get the node values of the element, node values from the element, and append it to our result. Let's check. Let's see what key is equal to. I think, yeah. Let's check. Oh, what's sort sort key is equal to lambda, and there is no comma here, I think. Yeah, I hope it works. Submit it. Oh, that works. That's pretty much about these problems. Thanks for watching.